Welcome to this comprehensive tutorial on implementing augmented reality features in Java. Today, we'll explore augmented reality, its potential applications, and how we can programmatically create AR experiences. Let's dive in. Before we jump into the code, what exactly is augmented reality? Simply put, AR overlays digital content onto the real world. Think of the popular game Pokemon Go, where you capture creatures in your surroundings. We will aim to create something reminiscent of that experience. We'll use Java alongside a library called AR Toolkit. If you don't have it installed yet, head over to the AR Toolkit website and download the library. Ensure you have Java Development Kit, JDK, and an integrated development environment, IDE, like IntelliJ or Eclipse setup. Let's start by setting up the project. Create a new Java project in your IDE. We'll call this project AR Demo. After that, include the AR Toolkit library in your project's build path. If you're using IntelliJ, navigate to Project Structure and add the JR files. Next, we need to create a layout file for our AR environment. Navigate to the res/layout directory and create a new XML file named activity_main.xml. This file will contain the surface for our camera feed and where we'll render our AR content. With our layout ready, let's move on to creating a camera preview using the surface view from our layout. We'll implement the AR activities renderer directly. Create a new class ARenderer which extends ARenderer. Now that we have a basic renderer, it's time to initialize our camera to display the feed in the AR view. We'll need to override the onCurfaceCreated method in our ARenderer class. Next, we need to set up the camera for augmented reality. Inside the onCreate method of AR Demo, we will set the surface view and bind it to the ARenderer we created. Now that we have the foundational structure in place, let's go ahead and implement a simple marker detection feature. Markers are images recognized by the AR system to place virtual objects in the real world. Create a new folder in your project's assets directory for marker images. In our ARenderer, we need to implement the marker detection in the onDraw method. This is where we will check if we can see the marker and render the corresponding AR content when detected. Let's create a method to render a simple 3D object when our marker is detected. In this case, we will use a simple cube. This involves more OpenGL programming, which we'll need to flesh out in our renderAObject method. Now let's implement some basic user interaction. We will allow the user to tap on the screen to change the color of the cube we rendered. This adds a dynamic aspect to our augmented reality feature. The Change Cube Color method needs to randomly change the draw color of the cube. It can be achieved by generating random RGB values, so let's go ahead and create that. At this point, we have a basic augmented reality application where a user can interact with a 3D cube rendered over a marker. However, let's enhance the experience by adding sound effects. We can use the Java Sound API to achieve that. We can play a sound whenever the cube is interacted with. Simply call our Play Sound method wherever you invoke Change Cube Color. Now, we have an interactive cube that alters color while sound plays. To polish our app, let's implement error handling for the marker detection to ensure the user has feedback if the marker isn't detected correctly. To enhance performance, let's implement frame rate control. This concept ensures our application runs smoothly, preventing unnecessary CPU usage. You can call this method in your rendering loop to maintain consistent frames. Set a desirable frame rate, perhaps 30 or 60 frames per second. Before we wrap up this tutorial, let's talk about debugging tips for AR applications. Since AR deals with real-world interactions, simulation becomes challenging. It's essential to test on real devices and ensure that markers are adequately lit and visible. Finally, don't forget to optimize your code to keep the performance smooth. Ensure clean rendering procedures to reduce lag and improve responsiveness to user inputs. Congratulations! You have now implemented a basic augmented reality application using Java. Remember, this tutorial primarily focused on the basics. Don't hesitate to explore further, delve into more advanced AR frameworks, and polish your skills. Thank you for watching. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to the channel for more exciting programming tutorials. Until next time, keep coding